Okay, I don't think this is the first time you've seen area and perimeter, but there's something about area and perimeter that we learn them at the same time, and it's hard for some people to distinguish the difference between them. So is anybody good at it and can tell me what the difference between area and perimeter are? Okay, so one way I try to think about perimeter, if you've ever seen like a crime scene investigation and the cops have their walkie-talkies and they will say, the perimeter is secured. Have you heard them saying they're walking around a house, they're walking around a building, they're walking around the crime scene, and then they report back the perimeter is secured. That's one way that you might be able to distinguish these. So the perimeter is the outer edge. You find the perimeter by adding, and it's one dimension. So in this room, an example of perimeter might be this rubber baseboard that you can see going around the bottom of the walls. It's going all the way around. So if they're installing that in, they're going to have to add this side plus that side plus that side. And then it kind of goes around the door weird, like a little piece there, a little piece there, a little piece there, all the way over here, a little piece there. They would add all those numbers together, and they would say, we need this amount of square feet. And it's the perimeter. Excuse me. The area is what's inside. Hello. We find it usually by multiplying things together, and it's 2 dimensions. So for example, this carpet on the floor, it's 2 dimensions. Can you imagine if you ordered 45 inches of carpet and they gave you this big long string that you'd have to wrap around the room? No, we get it in square units. It's a big roll, and it covers a space. These boards would be a square foot. So they would say, I need a 15 by 20, but it's the whole, again, can you imagine if they brought like this border, a perimeter of whiteboard? What would I do with that? So area, perimeter, like the baseboard. These ceiling things, you can see that the tiles are area. The metal supporting beams are perimeter. So you would measure 2 different things, a flat space or around the edges. Okay, so again, I just don't know if you guys remember this. Does anyone remember how to find the area of a square? Okay, we take the bottom dimension and we multiply it by the side dimension. So one way to think of it is side times side. What is S times S? What's a shortcut for writing that? S squared. I don't love the shortcuts, but they're worth mentioning. I just do base times height, side times side. So perimeter is around the whole edge, not just the 2. Some people just do 2 sides. They just add the 2 that are given. So make sure you remember a perimeter. Can you imagine if you fenced in your dog and you only did 2 sides? She would run away. So we have to do all 4. Side plus side plus side plus side. Is there a shortcut to that one? Yes. What's S plus S plus S plus S? How many S's is that? You can do 4S on squares. I don't love the shortcuts. I think they make it more confusing. But I use this way, shortcuts. Some people really like that. Okay, looking down at this example, it says to find the area and the perimeter. So capital A represents area, and the capital P represents perimeter. So we're going to do base times height, side times side. If you don't have a calculator, you might want one. You can do the shortcuts if you'd like. That looks confusing. 2.5 plus 2.5 plus 2.5 plus 2.5. You're going to fence all the way around it. All right, for that area, Bryson, what did you get for that area? On your notes, I want you to be very particular about your units of measurement so that when you refer back to them during your homework, you'll know what to do. Area is 2 dimensions, so it's centimeters squared. Area is always square units. Think of, again, the tiles in the ceiling. It's a square unit. This might be 2 square units. Yes? For area, you're multiplying. Area is 2 dimensions. You're multiplying 1 dimension by another. All right, Peyton, what did you get for the perimeter of our square? And these are 1 dimension, so it's just 10 centimeters. Now, if you don't think units matter, they do. So the other day, my daughter told me that the track team is taking the 3 or the 4 best people down to invitationals. Is that what it's called? Yeah. They're inviting you with an invitation to the invitational. And she's like, I was really close to being able to go. I was 1 unit away. And I was like, what was the unit? What was it? Was it like this? Are they measuring like this? Is it a yard? Is it a foot? Is it an inch? She's like, oh, I don't know. Well, you might want to find that out. I mean, if you're this close, you might get in next time. If you're this close, you might not get until the end of the season. So the units matter. That's a huge difference. Okay, let's look over at this rectangle. Yurasek, can you describe to us, if you were to say to somebody, what's the difference between a rectangle and a square? What would you say? Yes. They both have these 90-degree angles, so they're all over the place. Posters, doorways, desks. We see rectangles everywhere, and squares. But it's going to have 1 dimension. She said the bottom is longer. That is true. So because of that, we don't call it B and B, because they're different measurements. The area, same idea though, same idea. The bottom measurement and the side measurement, base times height. And we usually use lowercase. I don't know why these are uppercase. Most websites, you'll see it will be lowercase b and a lowercase h. Okay, perimeter. Any wild guesses on how you'd find the perimeter of this guy? Yes. Yes. Yes, and it actually helps to go and write them in, or most students will just do base plus height for perimeter. Their dog will escape. So how would you find it, Carly? Now that we've got them all written in? So for the fencing, for the perimeter?
Yeah, when you add the height.
Yep. I don't love the shortcuts. I just do this. Height plus base plus base. My dog will not be escaping. Some people like the shortcuts. So Hayden, what's h plus h? How many h's is it? 2 h's. 2b. So you can use either one of these. Again, I don't like the shortcuts. But like I was saying with this classroom, if you are always thinking of shortcuts and they give you a practical application like the classroom, you know how many dimensions there are? Like the front, the side, the back, the 2 little pieces by the door, this little part by the sink. Over here, we jog back by the computer. Like, if you're trying to think of shortcuts, it doesn't work. These shapes that we did, the graph of me, perimeter, there's no fancy formula. I'm adding up all of those lengths. Adding. So, again, shortcuts are fun if you have a really repetitive worksheet. All right, let's go down and find the area and the perimeter. Capital A represents area in geometry. Capital P represents perimeter. I like what Carly said, that she likes to put these around the edge when she's finding the perimeter, so she doesn't forget to use all of them. So Kennedy, what are the numbers that I'm going to use to find my area? Which is? Now I get really annoyed when they don't give you units. This is units squared. Even if you don't know what they are, this is carpet, this is ceiling tiles. Like my daughter, I don't know what units of measurement, it's really important. Maddie, what units do I use for the perimeter? not units, which numbers? So it's height plus base plus base. So what are my heights? Oops. It just wants to glitch. And what are the other ones I have to add? So my puppy does not escape all the way around. Again, think of the graphs of me. We add every single one of them together. Cooper, what did you get on that one? And again, I don't like when they don't put units, so we'll just put U. It's one dimension. It's around the edge. Think of fencing. What else do you guys do with perimeter? I don't know. All right, any questions on square and rectangle? Those are the two basic ones. Yeah. It's almost the exact same thing. Just that these are going to be the same number, and these will be different numbers. You do the same thing with them. It's still base times height, base times height. These are just always going to be the same number, where these will be different. And also, this is base plus height. So is this one, but all four will be the same number here. Same. Same formulas, though. All the way adding around the edges, multiplying the base and the height. Good question. Okay. I don't know what happened, but my notes for this wouldn't load, so I had to draw them last period. But I draw a pretty good circle, wouldn't you guys say? That's a pretty good circle right there. Okay, circles have a ton of their own vocabulary words. I don't know why. So it's not area and perimeter, it's area and circumference. So come in some of these empty spaces. Let's write that in. C means circumference. It's the perimeter of a circle. I mean, I don't know. It's just the perimeter. If for some reason you were going to put a circular fence for your dog, circumference is the perimeter. But it gets its own special name. Does anybody know what the R stands for? Who said it? Yes, Kennedy, that's right. It is the radius. Now, I don't know why in the picture it's a capital R. I've always seen it as a lowercase r. So down here, when you write what it is, please do a lowercase r. Somebody just use some fancy font. Okay, to find the area of a circle, you do pi r squared. What is pi? Where does it come from? This may or may not interest you, but mathematicians love, especially geometry people, they love the patterns that they see. So when you could take any circle, I could give you all different circles, and if you measure the diameter, which I haven't even told you what that is yet, so let's go back to our circle. If you take your radius and you extend it twice, so it goes all the way across, that has its own name also. It's the diameter. So please label it like this. A radius times 2 is a diameter. If I gave you circular things like Hershey Kisses, Ritz crackers, my clock, soda cans, anything that's a circle, if you measure the diameter, so straight across, and you write the number down, and you measure with a measuring tape around the circumference, and you write it down and you divide them, every single circle has that same ratio. It's 3.14159. And what else do we know about pi? Do you guys know that the decimals never repeat? Even with the technology that we have today with computers, no mathematician, no current mathematician has found any pattern in those numbers. They go on, that's what the dots are. They go on forever and ever and ever and ever. And this isn't a number somebody made up. You take a circle, measure the diameter, measure the circumference, divide them. Like, remember doing it longhand division? Mathematicians back in the day, they just kept going and going and going and going and going. Can you imagine? Paper after paper after paper. So they thought maybe with computers they'll find repetition. There's no repetition. That's why it's called an imaginary number. So it's so cool and so special. It has its own name and its own symbol. So the way we draw it, you do a straight line and a curved line, and you give it a half. But this is where it comes from. Maybe they don't tell you in middle school. You just believe them. Okay. Circumference is 2 pi r. Cody, what did I just tell you 2 r's become? The diameter. So sometimes you will see people say diameter times pi. That's the same thing. 2 of the radiuses are the diameter. So I'll use this one. I think it's easier to remember one, but if you look online or you watch videos or something, they're interchangeable. What else haven't I said? Oh, the definition of a circle is kind of cool. So the center is very important. And then it says every single point that is equidistant from the center. So let's say I pick 5 units. Then it would be 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 units away, 5 units away, 5, 5, 5, 5, 5, all the way around. That's what makes a circle. So the radius is very important. It's part of its definition. Okay, any questions so far on all these vocabulary words? That's cool though. Some of you should try it. When I taught school in Arkansas, they had a National Pie Day. Literally, the kids all brought in pies, and we brought in all these circular foods, and they measured things. They found pie. It was kind of cool. All right, here's your circles. You've got 2 of them. A smaller one, and they give us the radius, and a bigger one, and they give us the diameter. So let's start with the smaller one. Let's find its area. So pi r squared. Put that in your calculator. Does everybody know where pi is? So do you see the button that we had used for the power of, that little caret button? Look at the little blue above it. It's super blurry on my screen. So underneath clear, you've got your caret button, your TP, and the little blue pi. So in order to get those blue characters to work, you push second, and then the caret, and it will give you that pi symbol. My calculator? Oh, yeah. The company that the school bought like millions of calculators from, I said, can I get one to show on my board? And they're like, sure. Okay, go ahead and type these in. Pi r squared, 2 pi r. Plug those in, let's see what you get. And it says to round to the nearest 2 decimal places. Excuse me. Type those in, let's see what you get. We want to make sure we know how to use our calculators. Yeah, that's the area. Perfect. There's your perimeter. So we're going to have 2 areas and 2 perimeters. We've got 2 circles. Some of you are kind of writing your area over, or your perimeter over here. It says to round to the 2 decimal places. Five, but I didn't do that, so I wonder. Oh, here's. It was a 9. So it went up to a 4. The 4 is correct. Maybe you're thinking of a different one. Okay, Shaylee, what did you get for the area of our little circle with radius 5? And we do not have units of measurement. Makes me sad. Jared, what did you get for the circumference of our small circle? Yes. If you're not sure how to round, if it says to round to 2 decimal places, because this was 5, 3, 9, or something like that. So you look at the third space. If they want you to round to 2, you look at the third one. If it's 5, 6, 7, 8, or 9, 5 and above, give it a shove. 4 and below, stay low. All right, let's look at this next one. Maddie, I'm noticing on this big circle, they gave us the diameter, but I don't need the diameter for my equations. I need the radius. So what is the radius for this one? 16 is the diameter, which is all the way across, but all I need for my equation is the radius. Kennedy, what do you think the radius would be?
The diameter divided by 2.
Yes, so what is it? Take your, if they give you the diameter, cut it in half. And then plug it in. So do these last two. Matthew, have you found that area yet? What did you get? Perfect. No units of measurement. I don't know why that makes me so sad. And Corbin, what did you get for the circumference of that one? I got 2.7. What was after the 6? A 5? 5 and above. Give it a shove. Okay, let's go review the vocabulary that we learned for circles then. A radius is part of the definition. It goes from the center to the edge. It doesn't have to go out to the right. It could go anywhere. Sometimes kids are all thrown off if they draw your radius up this way and say the radius is 4. They're like, I don't know what that is. So the radius can go all the way around it. Diameter is 2 of those. So it's a radius, and a radius goes straight through the middle. Okay. Pi is the diameter over circumference. It's this really cool number that people memorize a million digits of, has its own symbol, has its own name, and we don't call the outside perimeter. I don't know why. They call it a circumference. Okay, lots of vocabulary for circles. Okay, our last picture, or shape, I mean, our last shape, triangles. Kind of confusing. On your picture of a triangle, will you add the A and the C around these sides? We know H, the height, we know B, the base, but these A and C are going to be important here in a minute. All right, when I think about triangles, triangles come from cutting rectangles in half, yeah? Or squares in half. So how did we find the area of the rectangle? Ethan, how did we find the area of them on the first page? Base times height. So would you agree that if I took my base and my height and I whacked it in half, I don't like the capitals, that I would get the area of a triangle? Yes, that's where the formula comes from. So this triangle is not a right triangle. This one looks different. But can you picture this? Half. Half, right? Can you see these are parts of a rectangle? Base times height. Cut it in half. That's how you find areas of triangles. Okay, the height is kind of tricky though. Like, why isn't this C the height? Or A? How do I know? If they're giving me these 3 numbers, how do I know which one I use in this formula? Yes. So it has to go from the very, very top of a triangle, so the very highest point, straight down to the lowest point. That's going to be the height of the triangle. And they are all over the place. Sometimes they're in the triangle. If you have a right triangle, it's the side of a triangle, like it is the triangle. I think your third picture has an obtuse triangle. Where is my obtuse one? On your obtuse triangle, the height is outside the shape. It's not even a part of it. So from the very top point, straight down, and like Miles said, it's going to meet, oftentimes they'll give you that 90-degree angle. So heights could be outside the triangle, inside the triangle, or a part of the triangle. It depends on if you've got a right triangle, obtuse triangle. Okay, let's look down at our example. Trying to think if there's anybody I've skipped calling on. Bronson, on my triangle right here, I know now that it's 1/2 base times height, but I'm confused with all the numbers. Which one would you use for the base and which one would you use for the height? Yes. How did you know that? It is kind of sitting on it, yeah. Hopefully you can see it. And then what's our height? It does say 7.4. It's the measurement that goes straight down from the top. And like Miles said, they'll often give you that 90-degree angle. Somebody left all their notes. All right, Hayden, what 3 numbers am I going to use for the perimeter of this triangle? Yes. I think those ones are more obvious. It's the sides of the triangle, but don't use 7.4. That is not a side of the triangle, not right now. All right, Corbin, what did you get for the area? The area would be units squared, kilometers squared. And Jared, what did you get for the perimeter? Just kilometers. If you try your best to do the correct measurements, area is going to be something squared. So try your best to remember that. If not, that's why I want you to be really particular in your notes. I think I'm going fast. Let me pause dramatically while you catch up with me. All right, we've got one more triangle to practice on because triangles don't always look the same. Rectangles do. The trickiest thing you can do with a rectangle is tip it on its side. Ooh, look how tall it is. But triangles are all sorts of different looking things. So this one's weird because the height, 1/2 base times height, is outside of the triangle. It's not inside it and it's not even a part of it. So Peyton, what are the 2 numbers that I use to find the area of this triangle? Yes. Hopefully, like Bronson said, you can kind of see it. But it is the one, when you do the height, it's going to come down 90 degrees, and that will let you know which one they want the base to be. Maddie, did you find that area yet? What'd you get? Oh, you didn't get it yet. Okay. I need to put it in your calculator. And then, yep. How do you find the area of a rectangle? Yes. So, for example, if this is 3 and 2, this is what it means it's doing. So back in elementary school, they would have given you tiles, you would have laid them on the picture, and then you would have counted them. So it means 3 times 2. This has a square unit, 6 square units. So triangles are half of that. It's taking all the pieces and cutting it in half. That's where the half comes from. If you just do base times height, you're finding too much. It's only half of it. All right, did you get this one, Maddie? What'd you get? And is there units? Yes, centimeters squared. And I don't think I've called on Bryce. Bryce, what did you get, or what numbers did you use for the perimeter? What numbers would you use then? And what? For the perimeter, so like the fence. Yeah, why don't we use the 8? It is not a part of the triangle. It's the height, but it has nothing to do with the 3 edges. Please be careful when you're doing those. Please be careful, because you kind of want to use all the numbers. Don't you just want to keep adding them all together? Okay, so my biggest hint to you is use your notes. Make sure you have all these formulas written down. If you're having a hard time, because we just learned all of this at once, when you get your worksheet, do the squares and the rectangles first then. Just skip around, do all the squares and the rectangles. Then go do all your triangles and focus on that. Then go do all your circles. Some of you can jump around, but if it seems like too much for your brain, put them in order yourself. And I don't think this is going to take the rest of the time. So if you get done quickly, make sure you find something quiet to do and stay in your seat and all that good stuff. And we don't get our phones till the bell rings. I'm sorry. So are you guys going to come to school tomorrow? No, because you're not juniors. I really think they'd let you on the bus. Then you'll have to call your mom and dad and have them come get you. Okay, there's a couple weird things about this worksheet. You guys will look at number 4 on the front. How would you find the perimeter if it only gives you 2 sides? Yeah.
Are the 2 sides the same?
For this worksheet only, if they just give you one of these slanted sides, we are going to assume it's isosceles. So number 4 is like that. Number 12 is like that. We don't have enough information. So looking at number 12, it's the same way. They only give you one slant height of 15. You need both. Okay, also look above number 7. This is on the back. Do you see how there's randomly just 10 inches? So this was a PDF and they converted it back to a Word document. You know how sometimes it like glitches? That is a glitch. It has nothing to do with the whole entire worksheet. Just at the top of 7, it says just randomly 10 inches. I don't know where it's supposed to be. I don't think it's supposed to be there. It's not even inches. So just cross that off. And then number 4 and number 12, assume they're an isosceles triangle. Okay, have fun with this. They'll go fast. Oh no, where's my recording thing?